मित्रांनो, up to last lecture we have discussed the case of gravitational potential due to solid sphere. In this big title, or under the heading of gravitational potential due to solid sphere, we have discussed three cases. See now, in which first case was gravitational potential due to potential due to a solid sphere. The point is outside here, outside the sphere. Another case which we have discussed, in that case the point was on the surface of the sphere, on the surface of the sphere. Whereas the last case we have discussed that gravitational potential due to a point which is located inside the sphere, here inside. In these three cases we have been calculated the gravitational potential. Today we will see about gravitational field, and again in which we will discuss the cases. See now, in beginning we have discussed about the gravitational field. What is gravitational field? Here again we will see gravitational field. See now, in beginning which we have discussed, once again we will repeat this thing, the space around. See, in the definition, the space around a body, around a body within which its gravitational force of attraction, its gravitational force of attraction, can be experienced is called gravitational field. See now friends, once again, the space around a body within which its gravitational force of attraction can be experienced is called as gravitational field. And now, due to this gravitational field to a solid sphere at a point, we have to discuss the different cases, in which first case is gravitational field due to a solid sphere at a point outside the sphere. See, we will see here the case in detail. Gravitational field due to a solid sphere, due to a solid sphere at a point outside the sphere. This is the case outside the sphere. Gravitational field due to a solid sphere at a point outside the sphere. Therefore, as we know that if this is a solid sphere, then here, if this is a point, then what is the gravitational field acting on it? We have to see. Therefore, the gravitational potential due to a solid sphere means that for calculating the gravitational field, in beginning we have been calculated the gravitational potential. Therefore, the gravitational potential due to a solid sphere at a point outside the sphere, in beginning we have been drawn the diagram, and outside the solid sphere the object was situated at a distance, a small letter r, and therefore the gravitational potential can be written, or we have been calculated, V equals to minus of Gm by r. This was the equation. Now, the intensity of the gravitational field at this point, intensity of gravitational field at this point is given by I equal to dV by dr. What is dV by dr? See, we will take here small letter r, means the distance, rate of change of gravitational potential with the distance is nothing but the gravitational intensity, or gravitational intensity of gravitational field, and this is nothing but d of dr by taking its derivative minus of Gn by r. And see, by solving it, the intensity I is given by minus of Gm by r square, and this is nothing but the gravitational or intensity of the gravitational field due to a solid sphere at a point outside the sphere. Now we will see gravitational field due to a solid sphere at a point inside the sphere. See, this is the case when the point is situated outside the sphere at a distance small r. Now we will see the gravitational field due to a solid sphere at a point inside the sphere. At a point inside the sphere. See now, gravitational field due to a solid sphere at a point inside the sphere. Inside the sphere. For calculating the gravitational field due to a solid sphere at a point inside the sphere, we have to, means we know the gravitational potential at a point inside the solid sphere at a distance, a small letter r from its center, and we have been calculated that thing v equals to minus of m into z in bracket 3r square minus of distance small r square and divided by twice r cube. This was the gravitational potential at a point which is situated inside the sphere. Now the intensity of the gravitational field at a point inside the solid sphere is given by, again as per the last case, I equal to dv by d of minus of m 3r square minus of small r square divided by twice r cube, and this factor g, gravitational constant, as it is. And therefore by solving or taking a derivative, we will get m z by 2r multiplied by 2r divided by twice r cube. And from solving these things, here we will get the things in this way equals to minus of d dr minus of Gm into 3 by twice r plus d of dr in another, by separating the term by taking this factor d of minus of gn r square divided by twice r cube, close this bracket, and see this derivative will be 0 plus we get mz multiplied by r 2r and divided by twice r cube, and therefore in another words this will be g, this 2 will get cancelled with this 2 and mgr. See this here it should be a small letter r, and therefore this will be the small letter r mgr upon r cube, no doubt with negative sign, and therefore the intensity here of the gravitational field the intensity of the gravitational field at that point is given by I equals to minus of Gm upon R square. Yes, sir. Okay, thank you.